welcome back. Let's finish up applications on determinants and matrices. So, using collinear formula, do you remember the formula that we were just talking about? 0 is equal to x1, x2, x3, y1, y2, y3, 1, 1, 1. When we calculate the determinant, if we get a 0, we know it's collinear. So what if I ask you this question? I want you to find y so that the following points are collinear. So again, if y is a special number, we know these are collinear. So we're going to check for that, okay? So let's do this. Let's just first start by plugging it in, right? -6, 2, 1, 1, 1. Okay, I'm just going to put the 1s there because we know that belongs there. -5y, -3, 5. I think you're kind of seeing how we're going to do this, right? So try it. Stop the video and see if you get the same thing as me, okay? So I'm going to calculate this as if I'm calculating the determinant. 2y and 5. 2y and 5, right? Now I'm going to multiply this. I don't know why I keep changing the marker. I'm going to multiply the diagonals, right? Does it equal, actually, we've got to ask yourself, does it equal 0? Okay, we don't know if it equals 0. So we're going to see what value makes it 0, right? So we're trying to see that. -6y, because I'm just multiplying the diagonals this way. So this way diagonals. -6y, -6, right? And then -25. Make sure you line it up nicely, okay? Minus, and then now we're going to go the diagonals this way. -3y, -30, -10. All right? All right, so let's do our calculations here. We're looking for y that makes these 3 points collinear, okay? That's going to be a -3y, right? Because we have a minus and a negative here, so plus. -6, that's going to be -31, right? And that's going to be -40, but it's positive 30, so it's going to be positive 9. So that means 3y is equal to 9, which means y has to be a 3. So what does that mean? Let's make a conclusion. If y was a 3, these 3 points would be collinear. If y was a 3. If y was a 3. Okay? That's how you do this guy. All right? All right, let's try another example. What if I asked you the question, find the equation of a line that passes through these 2 points. Find the equation of a line that passes through these 2 points. Now, equation of a line, there are many, many forms, but if you want, let's just do it in slope-intercept form, right? Y equals mx plus b, and remember, your m is not your mama, but the slope, and b is your y-intercept, and we're going to put it in that format, okay? So we don't know what to do with this using matrices, though. We have to use matrices and determinants, so we're going to use our same formula that we know. This special formula. It's a miracle how all these determinants have all these special applications, right? So we don't know, we only know 2 coordinates, right? So how about we just say, okay, these are my, I don't know, x2 and y2, and let's just leave the x1 and y1. So let's plug in what we know. So we don't know the first coordinate, because we only know 2. So 2, 4, 1, -1, 3, 1, and we're going to calculate the determinant, like we always do. Notice we haven't used the minors and cofactors method, so we're just using the diagonal method. I know, it's a little cheating, but it is a lot simpler, don't you think? All right, 2x2, just make sure that you copied everything correctly. So 0 equals, again, diagonals this way, 4x1, -y1, and plus 6. Again, diagonals this way, -4, we're just computing the determinant of a 3x3 matrix. -4, positive 3x1, and plus 2y1. Does that look good to you? If I make any calculation errors, just make sure you tell me, okay? Because I know that I could make some calculation errors. All right, so 0 is equal to 4x1, -3x1, right? So it's going to be 1x1, -y1, and we have a -2y1. So we got -2y1, 3y1, I'm sorry, and 6 plus 4, so it's going to be 10. So when I put this into slope-intercept form, and it's okay if you get rid of the 1s and x1 and y1, these little subscripts. So I'll just pretend that they don't exist anymore. So I'm going to go 3y is equal to x plus 10, which means y equals mx plus b. And this is what I get. So we're saying the equation of the line that passes through these 2 coordinates using matrix and determinants is this guy here. Of course, you know a ton of other methods, but if you want, you can also use this special determinant using matrices, okay? All right, good luck. Next video, we'll hold another application, which is really fun, but kind of long, okay? Just a warning. And try some problems before you move on to the next video. Bye.